Okay, when I look at these problems over here, since I start with the wrong U substitution, I'm looking at this one over here, I'm gonna say probably something to do with the a substitution of a secant, all right? So I'm looking at this over here, and I'm gonna say, I'm gonna let X equal 3 secant theta. Now, by the way, I have a, maybe not the best memory, sometimes I put the wrong thing down. It doesn't cost much to put the wrong thing down. You can always erase it and try again. I don't have many trigonometric substitutions to try, by the way, but I kind of recognize this thing as being a trig substitution problem. Let's write that down for you, and I'm gonna, be careful about it. I'm gonna write down, that would be 3 secant squared theta. Not 3, it's 9, sorry about that. Let me get my eraser out. Minus 9. Well, this is going to be, I factor a 9 out, it's going to be 3. And then you're going to get secant squared theta minus 1, which is the tangent squared theta. This works out pretty nicely, especially when we check these invertible regions, by the way. It's going to be 3 tan theta. I don't have to worry about the absolute value because the region, the tangent in that region is always going to be positive. So I think I have something that might work for me. All right, so I'm going to put this one down for you. So I'm just doing that substitution at this point, and I got the root done. It's 3 tangent theta. What's x cubed? It's 27 secant cubed. Now, granted, I realize sometimes that this is getting crazy. It may be going in like a direction where you can't even do that integration. If it's not getting easier, though, I'm going in the wrong direction. By the way, I don't see this as being easier at this point, but I'm not done writing things down. That's secant cubed of theta. I need to write down dx now. What's dx going to be? 3 secant theta tan theta d theta. I'll write that down for you. So it's going to be 3 secant theta tan theta d theta. Wow, that looks much worse than it was. Let's do a simplification now. And what do I see? I see 1/3. That's easy. Let's see what the secants I'm seeing over here. Well, what I'm seeing is, I'm seeing tangent squared on top. I got rid of the numbers, by the way, because 3 times 3 is 9. 9 goes into 27 3 times. One of the secants disappears and I get secant squared on the bottom. And that's d theta. All right, so I think I'm at least moving in a direction that's going to be somewhat helpful. I'm looking at this tangent squared over secant squared, and I just want to rewrite it on the side over here. Tangent squared is really sine squared over cosine squared. And the secant squared on bottom is just cosine squared on top. That cancels off. Wow, I'm getting something much simpler. I'm getting sine squared. All right, I'm going to start to get my eraser out. Again, I realize for some students, they say, why are you erasing prior work? I don't want to be distracted by that anymore. I think this thing is moving along in such a direction that I'm pretty clear that it's gotten simpler by doing that trigonometric substitution. So I'm over here, and I'm really focusing on this. I'm here, I'm wondering, how do you integrate that? And I want to reduce the power. So let me kind of remind you over here that, the cosine of 2 theta, you know what, I'm going to use x this time. Let me erase this over here. That the cosine of 2x is really the same thing as 1 minus 2 sine squared of x. All right, so I'm going to say sine squared x is equal to 1 minus cosine 2x. There's a 2 here. I'm going to divide by 2. And what do you get there? 1 minus cosine 2x over 2. I think I'm ready to do that. I'm going to pull a 2 on the outside, so you get 1/6. And then you're going to get, you know what, I should put a star over here too, because I'm really leaving the length of x's. We'll get back to that later, by the way. And what do I get there? I get 1 minus cosine, there's a star there too, of 2 theta, d theta. I'll keep moving along, and I need to integrate that guy now. So it's going to be 1/6. The antiderivative of 1 is theta. and that's gonna be minus sine 2 theta over 2. And there's gonna be some constant of integration over here. I'll call it C star. Well, I'm still not there yet. I'm gonna keep rewriting it. And I'm gonna, let me see what I can do over here. I get 1/6 theta minus, well, the sine of 2 theta is actually 2 sine theta cosine theta, and the 2 would cancel off. So I can say cosine theta sine theta plus some constant. And I gotta go back, and I'm sorry I erased it, but I do remember what I did, by the way. I do remember it. And it's unfortunately I erased it, by the way. But what I did was I said x equals 3. This is where I started. I should not have erased that, by the way. That means x over 3 is secant of theta. That means 3 over x is going to be cosine of theta. And someone says, what are you doing over here? Well, I got to get rid of that theta business. So before I do anything, I'm going to say theta is equal to arc cosine of 3 over x. The next thing I want to do is I want to figure out the sine of theta. So let's write this over here. This is theta. And I get the ratio 3x. What's this guy going to be here? Well, let's take x squared minus 9. So the sine of theta is going to be the square root of x squared minus 9 over x. Let's go back over here, and I'll write this down now. So 1/6. What's theta? It's the arc cosine of, again, I just forgot, 3 over x minus, what's the cosine of theta? Oh, 3 over x. What's the sine of theta? The square root, x squared minus 9 over x. And then plus c. I'm going to clean up a tiny little bit. You know what? I'm not going to clean it up. I'm going to use my eraser to do it. This is 3. This is x squared over here. All right, I'm going to look at the key now and see if I got it. And by looking at the key, I noticed I did some simplifications, but you know, it doesn't matter. I think I see this. 1/6 times that. And I'm seeing this too. And I'll tell you why. 3 goes into 6 2 times, so I get 2x squared, and I see that. Yeah, it looks good. We got it. Thank you.